Hello everyone, welcome to NCX Tech, and today in this video we're going to discuss on adherent point, limit point and isolated point of any set. So let's start with adherent point, and for this let's consider a set A, which is a subset of R, that is set of real numbers, and then a point C, which is a real number, is said to be an adherent point of A if they will have condition if for all R is greater than 0, for all positive R, the ball with center C and radius R, this intersection with A, this is never empty. So this is not going to be an empty set. This means the intersection of this ball with center C and radius R with A, it's not going to be an empty set. At least one element is going to belong to their intersection, and we can give one example for this. Let's say for any set A, supremum of A is an adherent point of A. So we can clarify this by one specific example. So let's suppose an open interval 0, 2. So here it is very clear that this 2 is the supremum of this set. Let me call it A. This 2 is supremum of A, and even if we visualize this in a normal line, suppose there we have 0 and there we have 2, so we can see that every ball we draw with the center 2, no matter how small is the radius, so this is the open ball with center C and let's say radius R. Here in this case C is 2, ball with center C and radius R, and it is very clear that this open ball contains some element of this set A. Here you can see the intersection part. So we can say that the intersection of this ball and the set 0, 2 is not empty, because here we have some elements to their intersection. So we can say that supremum of a set is an adherent point of A, and also same applies for infimum. There we have 0, and all the points inside of this interval, these are also the adherent point of this set. So this is all about adherent point, and let's talk about limit point. Okay, so again consider a set A, which is a subset of real number, and then a point, again let's say a point C belongs to R, is a limit point of A if, and there we have a condition that that the ball with center C and radius R, and this is for all R greater than 0, and intersection with A. So in case of adherent point, this shouldn't be an empty set. Here also this shouldn't be an empty set, but here we have one extra condition that the intersection of these two sets must contain at least one element except C. So here is the big condition, except C. So this is the definition of limit point, that the intersection of the point the ball with center C and radius R with intersection with the set A must contain at least one element apart from C. Okay, and if such condition happens, then this point C is said to be a limit point of the set A. And also here we can give one example for this. So for this, let's consider set 1 by n such that n be a natural number. So this means we have the set 1, yeah, as we vary the value of n, we get to 1. When n equal to 2, we have 1 by 2, 1 by 3, 1 by 4. It keeps on decreasing, you know, and it goes on. Okay, and let's say this set to be A, and here we have 0 is limit point of A. 0 is limit point of A, and we can verify this, you know, that 0 in this set, 0 never belong to this set, you know, because 1 by n, this will be 0 only when we have the value of n is infinity, and that's not going to happen here. So this 0 here is the limit point, because if we draw a ball, an open ball with center at 0 and a radius no matter how small we can take, the intersection with of this ball with this set is never going to be an empty set, and it contains some other elements apart from 0, and it's very clear, you know. That's why we can say that 0 is the limit point of this set A. And next let's talk about isolated point. Next we have isolated point. So again let's consider A to be a subset of real numbers, and then a point let's say C, a point, and this belongs to A, is said to be an isolated point. Isolated point of A if, and now there we have the big condition here, that if ball with center C and radius R intersection A is nothing but the same point C. Okay, and this should not be true for all the open ball, but we can write here if there exists R greater than 0. So we have to find out one open ball so that its intersection with the set A is nothing but the point itself, that is C here in our case. Okay, and for this also we can prove this by we can visualize this by one example. So for this let's consider a set A which is equal to, let's say, 0, 1 and union with 2. Okay, so here we have this. So here in this case we can visualize this set as here we have 0 to 1. This is the open interval, and there we have separately 2 here, and this whole interval, and this single point 2, and all this combines with the set A. And now here we have let's consider a radius to be 1 by 2. Okay, 1 by 2, R equal to 1 by 2, R equal to 1 by 2, which is greater than 0. So we have found out a radius for the open ball such that ball with ball with center 2 and radius 1 by 2. Okay, and its intersection with A. Let's see what we get here. So here as we have taken r equal to 1 by 2, so here we can draw an open ball. So this is ball. So while we have this distance is 1 by 2, so this is the open ball with centers at 2 and radius 1 by 2. So here in this case, the intersection of this open ball with the whole set A, while this whole set contains 0 to 1, the whole interval, but only this point 2 belong to this set A, and the intersection of these two is very clear that it's nothing but only 2, so it satisfies this condition for isolated point. So in this case, this point 2 is an isolated point of the set A. Okay, and here we have definition for closure of a set. So here we have set of all, as we have already discussed on adherent points. So set of all adherent points of set A is called closure of A, and it is denoted by A bar. Okay, this is denoted by A bar, and similarly the set of all limit points of a set A is called derived set. Okay, this is called derived set of A, and it is denoted by A dash. Okay, so this is all about adherent point, limit point, and isolated point. So I hope you got the idea about these points, and if you still have some confusion, you can comment down below. And if you found this video useful, please like and share this video, and subscribe my channel for more higher mathematics related video. Thanks for watching. Have a nice time.